All right, this is electrical 2, module 5, pole and junction boxes. Pull up some slideshows, electrical 2, pole and junction boxes. All right, so page 1, module number 26205-20, boxes and fittings, section 1. You need to know these trade terms: explosion proof, junction box, pole box, rain tight, water tight, weatherproof. Those last 3 are going to be important to know. They're going to ask questions on those. I think we have highlights later in this chapter on those. But at least just to me, rain tight, water tight, and weatherproof kind of all sound the same. So they are not the same. So make sure you read through those trade terms here on page 1, and then again whenever we're going through this chapter, and make sure you know the differences of those, because you will have questions on those. First highlight, page 1, section 110, pole and junction boxes. First sentence: pole and junction boxes must be sized, installed, and supported to meet the requirements of the NEC Article 314. Article 314 covers pole and junction box requirements. Page 2, going into section 112, NEMA and IP enclosure classifications. So these are going to be different NEMA, the National Electrical Manufacturers Association. So this is who says that this box can be for general purpose, dust-proof, rain-proof, waterproof, weatherproof, all that stuff. They're the ones that make these classifications. And I've got several highlights for the next bullet points that are going to be on these classifications. So make sure, I would read through all the bullet points, but make sure you know what the differences are in the different identified use for boxes and how NEMA has identified them. So my first highlight is the whole first bullet point in 112. NEMA Type 1 general purpose box. This enclosure is primarily intended to prevent accidental contact with enclosed apparatus. It's suitable for a general purpose application indoors where it's not exposed to unusual service conditions. A NEMA Type 1 enclosure serves as a protection against falling dirt but not dust tight. This is what, if you've done electrical or you're doing this electrical in the lab, like we've got the box in the lab that we're popping holes out of, just to learn how to use that hydraulic knockout punch. Sorry, I was lost train of thought for a second, but my hydraulic knockout punch. So that box that's out there would be a Type 1 general purpose. It's not made to be outside. It's not going to block, not dust tight. It's not water tight. It's just a general purpose box. And the reason they separate these, like obviously this would probably be one of the more cheaper boxes. Like if you had this box in any other category, the same size and everything like that, but like watertight or rain tight, it's going to be more expensive because it's going to have seals. It's going to have different coatings, might be painted or powder coated or something like that, like to keep the different stuff off of it. But out to the side of that, I wrote residential basement. So this would, obviously we don't have basements here, but the ones writing this book, this would be the panel that would be in your basement. Or for, we don't really have, most of our panels down here in Southeast Louisiana are outside of the house. But if you have a panel inside your house, this would be kind of what that would be. My next highlights in the top right of page 2, that NEMA Type 4 watertight whole paragraph is highlighted. A watertight enclosure is designed to meet a hose test, which consists of a stream of water from a fire hose with a 1-inch nozzle, delivering at least 65 gallons per minute. That's a lot of water. The hose is directed on the enclosure from a distance of not less than 10 feet for a period of 5 minutes. During this period, it may be pointed in one or more directions as desired. There should be no leakage of water into the enclosure under these conditions. Out to the side, I wrote, this is for like regular wash down. So you might work in a plant where they have something where you have to go wash down different things. A lot of food industries have this. They have a room. It's about the size of this. It might be about the size of this classroom, but you can hang stuff up on the walls, spray them off with a power washer. If you have electrical boxes in that room, they should be watertight. But that's how they check them and make sure that they're watertight, by using a fire hose and subjecting them to tests that make sure that they're watertight. Skip a bullet point, and I've got the NEMA Type 7. First sentence of that is highlighted. Hazardous locations, Class 1. These enclosures are designed to meet the application requirements of the Class 1 hazardous locations. The next highlight is on page 3, and it's right after that last bullet point, that last paragraph before 120. I've got a couple, 3 sentences highlighted in that paragraph. Table 1 provides an explanation of the ingress protection IP classification system. Each enclosure is designed or designated IP followed by a 2-digit number. This is what you want to key in on. The first number describes the level of protection against solid objects, and the second number describes the degree of protection against water. So if you look over at table 1 down at the bottom of the page, so you can see the first number either up here on the board, 0 is not protected, all the way up to number 6, which is dust height. And the second number, 0, again, not protected. 1 for water would be protected against water dripping vertically, such as condensation. So not very much water, but protected against it, all the way up to number 8, protected against submersion. So you can take the box and submerge it underwater. So you go from pretty much nothing all the way to being able to submerge the box. So a wide range for these different types of boxes. So you just need to know that there's going to be different types of boxes that can prevent different types of contamination. Fittings. You're going to have different types of fittings for these boxes, and it usually depends on the type of wire that you're using or the type of conduit that you're using. So they have EMT, which is thin wall tubing. You can't thread it, so you have to use certain types of fittings for that. Flipping over to page 4 and 5, you can see a couple of the EMT compression fittings or the set screw fittings. These are the compression fittings or rain tight compression fittings. I've actually never seen these. These are usually I just see regular compression fittings, but that's what you're going to see if you're in this classroom or come back in this classroom. They have compression fittings. They're just not watertight compression fittings. This is pretty much what they look like. They just have that rubber coating on them. And then you have set screw fittings. These are the cheaper version of EMT. Really easy. Just put it in there. There's a little stop halfway through where your pipe stops, and then you secure that pipe with 2 screws tightened tightly to the piece of conduit. No highlights in EMT fittings, but you need to know that they're out there. 122 rigid, aluminum, and IMC. Nothing highlighted in those, but you can see the different ones. I do have a highlight at the bottom. You can see this picture that I've got on the board is figure 5 at the bottom. I highlighted that. You need to know what that looks like, but that is a flexible to a rigid coupling. So you can see the threads on one side, and then the other side is just going to be open, so you can put a piece of flex in there and then tighten it down with that screw. Lock nuts and bushings, 1, 2, 3. First paragraph, second to last sentence is highlighted in 1, 2, 3. A grounding lock nut may be needed if bonding jumpers are used inside the box or enclosure. So this is your grounding lock nut. You need to highlight this over on page 5. And you know what this looks like, but it just looks like a lock nut, but it's got a screw on it so that you can put a wire on this and ground out the box. Directly to the right of that highlight in that middle paragraph on the right-hand side of the page, I've got the end of that paragraph highlighted. Any underground conductor, 4-gauge or larger, that enters a cabinet, raceway, box, or enclosure must be protected by a method in accordance with NEC section 304G, 312.6C, and 314.17C. So big wires got to be protected when they go inside the box. They're going to have some type of bushing or something like that to make sure the insulation is not going to be ripped off the outside of the box. But that is 4-gauge or larger. Flipping over, still talking about fittings and bushings, lock nuts and bushings. The first full sentence on page 6 is highlighted. Myers hubs are gasketed fittings with an integral O-ring to provide a watertight seal for enclosures installed in wet locations. So you can see those. That's a Myers hub up here on the board, or you have one on page 7. If you're in the lab and want to see one, I have some in the toolbox. These are what I preferred to use whenever I was working in a plant. We didn't use any EMT in a plant. We used all rigid, so this would be rigid. So you would put this on the outside of the box, and then you would screw your conduit into it on the outside. But this takes care of all your bushings and everything like that. Like it has this internal an internal bushing so that your wire doesn't get scored on when you're pulling the wire through into the box. But these are expensive. The ones like the bigger ones that I used to use, I think they told us they were like 10, 12 bucks a piece. So they're pretty pricey, but I like using those way better than than messing with all these bushings and stuff coming into a box. We just use Myers hubs where I worked. On page 7, you can see those knockout punches. We've got like the screw type knockout punches, but we also have the big hydraulic one as well. We do not have the battery powered knockout kit. That would be super nice. But hydraulic knockout kit we have, which is pretty much like what is on page 8. Then you can see like they have stainless steel gasket hubs. So if you have stainless steel boxes and stuff like that, you might have to make sure to use stainless steel. Step bits. Step bits are used quite a bit in residential. You can see that step bit on page 8. But in a pinch, a step bit is nice. They're just, honestly, I had one. It's about 40 bucks. No idea where it is. They're easy to lose. They shouldn't be easy to lose, but they are expensive. I'd much rather just use a knockout kit when I'm doing this. But for ease and quickness, you can make a hole with a step bit. That's all for section 1. Going into section 2, sizing pull and junction boxes. So I can't remember exactly what was in electrical 1, but you did some of this. It goes a little bit more in depth here in this section. Several highlights on page 9. Page 9, I've got 6 highlights just at the end of the page. So 210, sizing pull and junction boxes for systems under 1,000 volts. First bullet points highlighted with, you'll have 3 questions. In a straight pull, the length of the box or conduit body shall not be less than 8 times the trade diameter of the largest raceway. That means you take your largest raceway in the box, so say that's 4, and it can't be, your box can't be less than 8 times 4 wide. So your box would have to be at least 32 inches wide. Excuse me. Next bullet point, got 3 highlights in. Where an angle or U-poles are made, the distance between the raceway entry inside the box or conduit body and opposite wall of the box and conduit body shall not be less than 6 times the trade diameter or metric designator of the largest raceway in a row. This distance shall be increased for additional entries by the amount of the sum of the diameter of all of the raceways in the same row on the same wall of the box. Each row shall be calculated individually, and the single row provides the maximum distance that shall be used. All this is saying you'll have problems to go on this, but just going through. I didn't have the slides going for this one. So, straight pull box. This was a straight pull box. I've got the length right here. Pull. So, straight pull box, my largest raceway into the box is 4, just like I said. So my length of this box would have to be 8 times 4, which this box would have to be 32 inches wide. The height of this box or the width of this box just has to be sufficient enough to where these conduits can fit in it easily, or well, you can't pack them in there too much. For angle pulls, the minimum length of the box is 6 times the trade side of the largest conduit. That's the first thing. So largest conduit coming in on one wall is 4. 4 times 6 is 24. So 24 is what we're going, largest conduit plus the sum of all other conduit diameters entering the box. So we have 24, and then we add the other 2, 24, 25, 26, 27 for the 3-inch. 28, 29. So our box has to be at least 29 inches tall. You're not going to have a 29-inch tall box. You're probably just going to go ahead and buy a 30. Don't buy a box where everything's going to fit tight. You might ask, like, why would an angle pull have to be less than a straight pull? If you think about it, you could pull, usually how you pull wires, you're going to pull all this out into the floor and then put it in and pull it the rest of the way, because this is a pull box. So this is easier to do. It's easier to get this last corner in at an angle rather than going straight in. So if I go back to the other picture and I go in straight like this, and these are big wires, I get them pulled off in the floor, and then the hard part is getting them to go back into here. So my straight pulls have to be wider so that I can have enough bend in that wire to push it down flat into this box. If it's too close, I'm gonna have a big loop out here that I can't get down into that box if the wire's big enough and stuff like that. So you have to be wide enough to where you can get those wires to lay flat inside of that box. One second. No, it's no big deal.
Oh, you was recording.
I'm recording a lecture. Are you here to take tests?
Yeah, that's my
All right. Are you ready now, or you need to study a little bit?
I intentionally left the quiz an answer because, like, this course is, you said this test would be hard, so what I wanted to do is, like, I wanted to run through the quiz so it's fresh in my mind, like the answers and stuff.
Okay.
Do the test.
All right. Go ahead and do that. I'm just going to keep recording this lecture.
Got it.
So that is all my highlights on page 10. You'll have several of these to work through in the work in the back of the chapter and on the quiz. But like I said, you got 6 questions coming out of sizing pull boxes. Moving on to 220, sizing pull and junction boxes over 1,000 volts. So same thing, but your box is going to have to be a little bit bigger. So going on to page 11, 220. All of the first bullet point on page 11 is highlighted. For straight pulls, the length of the box should be at least 48 times the outside diameter of the largest shielded or lead-covered conductor entering the box. So you're looking at the conductor. When the cable is unshielded, the length of the box may be reduced to 32 times of the outside diameter of the largest non-shielded conductor entering the box. So you want to make sure, if it's shielded, it's 48 times. If it's unshielded, you can reduce it down to 32 times the outside diameter of the box. Remember, that's the conductor, not the actual raceway size. Next bullet point. Just about everything except the last sentence is highlighted. I've got 4 questions that come out of these couple sentences. For an angle or U-poles, the distance between each shielded cable or conductor entry inside the box and the opposite wall of the box must be at least 36 times the outside diameter over sheath of the largest cable or conductor. See NEC section 314.71b1. The distance must be increased by the sum of the outside diameters over sheath of all the other cables or conductors entering the same wall of the box. So for boxes over 1,000 volts, you're using the conductor size. Under 1,000 volts, you're using the raceway size. And you want to make sure for these questions to keep your multipliers correct between straight pulls, angle pulls, shielded cables, unshielded cables. And I have 4 different sections in that one. The last bullet point on page 11 is also highlighted. Per NEC section 314.72e, Boxes housing conductors over 1,000 volts must be completely enclosed and permanently marked danger, high voltage, keep out. That's all for section 2. I'm going to move straight into section 3. Section 3, specialty enclosures. Need to know what a conduit body is. We've talked about that in electrical 1. You should know what a conduit body is. We'll talk about different types, how to identify them, and what they are. Mogul is also going to be another one. I think all these trade terms we're going to end up highlighting in this section. So make sure you know the trade terms. 310, conduit bodies and other cast enclosures. 311, type C conduit bodies. Up here on the board is a type C conduit body, or it's also figure 17 on the next page. My highlight is the first sentence of this little short section. A type C conduit body may be used to provide a pull point in a long conduit run or a conduit run that has bends totaling more than 360 degrees. So what's nice about a type C conduit body is that instead of a pull box, I can put one of these in for like smaller wires and smaller runs and use this as a pull box, and it doesn't have to be mounted to anything. It can just act as part of the pipe, so I can pull all my wires through this type C conduit body and then run them down the other side, and I reset that 360 degrees of bends whenever I have these. So if you got a lot of bends and stuff like that, or even if you have like maybe not 360, but even like a higher number of bends where this pull is going to be hard, put a couple conduit bodies in there, and then you can use them as pull points. Type L conduit bodies. Got 3 different types. I think they have 4 different types of conduit bodies. Type L conduit bodies. You should remember how to look at these, but pretty much the highlight that I have in this is the last sentence of 312. Type L conduit bodies are available with a cover on the back, which is type LB, on the sides, which are type LL and LR, or both, which is a type LRL. So the way you recognize these that they teach is you hold it like a pistol. So this first one all the way to the left, I would hold like a pistol, and the cover designates which one it is. So this would be a type L conduit body. The cover is on the left. So the first one up there on the screen is a type LL. Second one, you have the covers right on the back or the top. So this would be an LB. And then you look at the other one and you hold it like a pistol and the cover's on the right. So this would be a type LR conduit body. I've never seen one, but I think they show. They don't show one. They make a type LRL where it covers on both sides. I've never seen one in my experience, but there's probably one out, and obviously there's one out there. Type T conduit bodies. 313. Last 2 sentences on the page are highlighted. The cost of a T body is more than twice that of a standard square box with a cover. Therefore, the use of type T conduit bodies with EMT is limited. So you have a T. This is a T conduit body. So they're saying these are pretty expensive. I looked them up. I think they're $20-$30 for this type T conduit body. And while that looks nice, a regular box is $2. So you can use a regular box instead of a T. So you want to make sure that you know that this is a type T body. And then our last one is a type X. Don't get this confused with a type T, even though that looks like a T. This is an X. So an X has 4 different outlets. A T only has 3. So don't get those mixed up. But in 314 on page 14, first sentence is highlighted. The type X conduit body is used to provide a junction point for 4 intersecting conduits. So T is 3, X is 4. 315, type FS and FD boxes. 315. My highlight, I got a couple of highlights in this section. First paragraph, last sentence is highlighted. FS and FD boxes may be used in environments defined by NEMA 1, which is dry or clean environments, NEMA 3R, outdoor wet environments, and NEMA 12, which are dusty, oily environments. Last paragraph on page 14, first 2 sentences are highlighted. Engineers specify and electricians install FS and FD boxes for a reason. Never alter these boxes by drilling mounting holes in them. So these would be, I wish they had a picture, but So these would be like the outdoor boxes that you have that you put on the outside of your house. Just regular boxes, but they're saying don't drill into the back of them to mount them or anything like that. They have little ears that come with them that you screw to the back and you can mount them on stuff. But these are type FS and FD boxes. 317 on page 15, entrance L's or SLBs. First sentence is highlighted. An entrance L or SLB is built with an offset so that it may be attached directly to the surface, that is to have a conduit penetration. So entrance L would be this. So it doesn't have, there's no offset, so it can come straight in. This pulling elbow will be off of your box a little bit. But you need to know that this entrance L is also called an SLB. Moguls 318. Again, I've never seen one of these. This is what's up on the board. I'm sure these are used in big installations where they need them. It seems kind of like an emergency fitment to get stuff inside of a conduit body. Say my highlight, then I'll talk about it. 318, first couple sentences are highlighted. Mogul conduit bodies, figure 22, are up on the board, are available in the same types as the standard conduit bodies, type L, T, and so on. They have a raised cover to provide better access to large conductors during conductor splicing, installation, or maintenance. Let's just look one up, 2 seconds on Google. So we'll say Mogul conduit body. So we go try to find the one that we're looking at in the picture. So this one right here, they're charging $1,600 for this. So you can see why people would not want to use them. I mean, there's obviously some cheaper ones right here, but $1,500, and that was $124. So, I mean, this is a 4-inch one versus 6-inch. Either way, you can see how stinking expensive that these are. So a lot of people, like I've said, I've never seen one, never used one, but they're out there and like it's good to know that you have this stuff, have access to buying this stuff if you absolutely need it. Hand holes 320. So these are what you see everywhere in the streets and stuff like that to get access to big electrical boxes. These are got a couple highlights for hand holes on page 16. Online test question. And I've got 3 questions. One's an online test question, one's regular question, one of them is going to be a review question. So you need to make sure you note this. So last bullet point on page 16, I've got most of it highlighted. Per NEC section 31430D, handhole enclosure covers may have or shall have an identifying mark or logo that prominently identifies the function of the enclosure, such as electric or traffic signals. Next highlight, to discourage unauthorized entry, handhold enclosures must be either weigh over 100 pounds. Key in on that 100 pounds. That's the way you get either over 100 pounds or require the use of tools to open. So this one right here doesn't look like it weighs 100 pounds, but they've got bolts in the sides to make sure that they you have to have tools in order to get that up. Handhold construction, ANSI requirements. Are both on there, but those are the last of my highlights for this section. So you've got section reviews, module reviews are useful to do, and then you have the quiz, supplemental exercise. But that's all I've got for pull and junction boxes for this chapter.